Hello and welcome. If my mic is on, that is on. For those of you probably following me around the scale track, I am Amy. Once again, I am here to introduce Michael from MetLife. Michael from MetLife. He's talking about tuning Jira Horsepower, tuning Jira software horsepower for performance at scale. He has 6 guitars, a mandolin, a banjo, a bass guitar, and says that it's the only part of his life that he is highly strung. So if you want to chat to him about his crazy music ambitions afterwards, you can do that, or you can chat to him about tuning Jira Horsepower for performance at scale. But I'm going to introduce him up onto the stage, so please welcome Michael.
Thanks very much, Amy. I sent Amy a number of different fun facts. I was wondering which one she would use. So I've got about 2 more for my next talks. So everybody, so my name is Michael Brosnan. I work in MetLife in Galway in the west of Ireland. I run the Atlassian user group in Galway, and it was great to meet all of the people from the user groups yesterday. So my talk is about tuning Jira for scaling and performance. So there's 4 talks in the summit this year, specifically around performance. Obviously, it's a big interest. The reason we talk about performance is we want a service assurance for our users. It's if people have a responsive system, they have a good experience with Jira. Jira looks good, we look good, and so on. So my experience of working with Jira at scale came from working in administration of a system. It went from 50,000 issues all the way up to 2 million issues over the course of 2 years. So that's scaling Atlassian in a very dynamic environment, because there's lots of things happening. It's like being in a race car in the pit crew, except you're actually on the race car going around the track. This is broadly what the talk is going to be about. I'm going to talk first about how we got into the situation of growth, and then how we address the concerns we found. Just talking about general performance tools that any system administrator would use, and then get into more specifics. That's very sensitive. Let's put it down. More specifics around Atlassian-focused administration tools. What really helped us in our journey for managing performance was the Atlassian testing to get benchmarks about. First of all, the understanding sample customers, understood where our instance was against other customers, getting a deep understanding about our relative custom fields and workflows relative to other users. As we scaled, we understood we were working on performance. We were also implementing Jira Data Center, so understanding how Jira worked and how it performed helped us to understand more about the data center implementation. That's understanding how read is distributed across nodes, but writes are going to affect all nodes. It's understanding about the different indexes within Jira, and also data center implementation is going to be about the traffic shaping that you need in order to segment API traffic. And then I'll summarize with some lessons learned about that. So we're in the Scaling Atlassian track. We're one of 4 performance talks. So we're here as administrators because we're either using a busy Jira system, administering a busy Jira system, somebody maybe even paying for a Jira system. There's actually people that are considering adopting Jira that I've met before I came into the talk as well. So there's lots of different users, but the concern is, can we get control of the system and make it work? So, from my experience with Jira, the way that user growth happens, sometimes it's in a very high control mechanism where you've got upfront planning of what templates you need, how projects are going to be set up. Other times, the users are basically learning about Agile at the same time as they're learning about Jira. So there's kind of experimentation about, do we do it this way, do it the other way. So so basically, in our situation, we were on the right-hand side. We're learning about Jira as we're learning about Agile. So how do you get to 2 million issues? So what I found is that certain growth can be organic as a team onboards onto to working in an agile way. They're going to break down their stories. You're going to end up with 100 stories. That project, it's a ghost machine. The slides are auto-advancing. The growth is as fast as the uptake in agile usage. Other times, maybe we had a head start. So that's the situation we found ourselves in. We had other agile planning tools used previously to Jira. We also had multiple Jira instances merged into one. We also had multiple integrations that were syncing issues into Jira. So now that's the engine for growth, as well as the organic growth, import and API traffic growth. So now we've got a certain scale of usage on Jira, and we start to get feedback on performance. So what's happening? We've got a stand-up. Stand-ups work the same way in every company. It's the same script. What did you do yesterday? What are you going to do today? Have you got any blockers? So if we're doing this stand-up and we've got 100 projects, everybody doing a stand-up, so we end up with a crunch on usage of Jira. So if that starts to impact on performance, and we've got API traffic as well, then we can easily see that we're going to have a period where there's going to be a performance concern with Jira. The other thing is that we're in competition with a low-cost alternative. If you talk to Agile purists, they hate tools. They prefer the kind of one-to-one interaction. But we're in a scaling Atlassian talk. We're at Atlassian Summit. This isn't a philosophical debate about whether you need Agile, you need tools or a board for Agile. So, give you my opinion on whether you need tools or not. So, if the post-it that's semi-stuck to the wall falls on the ground, nobody got notified if it's stuck to the wall. If it's in a Jira board, you can get notified. You can report on it. As I said, when we get to the point of getting feedback on performance, we'll start to get feedback like this. If you're an administrator, hands up if somebody ever gave you this kind of feedback about Jira. I thought Jira was a bit sluggish today. It's a nightmare, isn't it? So this isn't even a ticket you're going to get. It's going to be feedback in a corridor. What they're trying to tell you is that maybe you're not good at your job, maybe Jira's not great. So what they're really telling you is that I don't know when it happened. I don't know what I was doing. I don't know what I changed. So this is an intractable support problem, and as an administrator, we take pride in our work. We want to give an assurance that the system that we take pride in is going to work properly. So these could be considered intermittent issues or outlier issues, but it's more satisfying to go after these and prevent these from coming back. So if we take the first pass, we're going to look at the basic first measures you're going to have. How hot is this system running? This is running on a Windows or Linux system. What's happening with the CPU? Next, if we start to measure the web requests that are coming into the system, what's the traffic coming into our system? If I plot this over time, is there more than normal? So basically, usually in these curves, as I'm describing everybody having a stand up early in the morning, usually there's a peak in activity in the morning, there's a dip for lunch, and it never quite hit the peak afterwards. So I think everybody in this room, you all look very bright. We're past the post-lunch slump. So the premise of what I'm talking about is that to understand performance, you need to know more about how Jira works, because then everything that's in the knowledge bases has more context and is more relevant for how to attack the problem. There's seriously something wrong with this clicker. So first thing is to understand the infrastructure it's running on. So it's understanding your available CPU capacity, number of cores, the speed of those cores, your I/O performance of local disks, and your database latency, database performance. The important thing as well is that it's about the configuration as well as the usage. So it's not just the big numbers, like the number of users or the number of projects. It's the usage patterns of how Jira has been configured, how APIs have been configured to integrate with Jira that influence overall performance. So the other point to emphasize is that all the information I'm referring to here is in knowledge bases that are available for everybody to get at. So the title of my talk is Jira Horsepower, and originally I had a famous stock image of, I think, an overloaded cart with the horse in the air, but I think that's not very empathetic to the horse, so I took that out. So what I'm saying is that Jira Horsepower, what I call it, is it's Jira's capacity to handle requests. So some things are adding to that capacity, some things are taking it away. So it's poor configuration and poor usage patterns that are taking it away. So I want to go deeper into the specifics of that. And if you saw the keynote this morning, the lady that was giving a talk about Jira Cloud was talking about a performance index. So that's what I'm referring to here is effectively the ability of a system to handle requests. So to understand how we're going to attack the problem that we're experiencing, first of all, what's Jira used for in the first place? Because we need to know more about the usage patterns. So Jira is there to emulate and support agile planning. So it's a fairly straightforward thing if you break it down. And the proportions of activity determine of what's happening. So first thing we're doing is we're creating an issue. So if you look at the activity in a system, relatively small amount of issues are created versus interacting with boards and so on. We're moving an issue, as in we're updating status and so on. So ultimately, when you look at traffic patterns, what's really happening is that most interactions with a Jira system are to do with searching. And searching is a request comes in, Jira processes it, and returns a response. There's auto timing on this that shouldn't be there. Anyway, so when we're performing a search, we're asking Jira to basically return some data. So the less refined the search is, Jira has to do some more number crunching, then it's going to be a bigger load on the system. So that's the first thing to understand about integrations, to be mindful of the data you ask for and the data that you want to be returned. So as administrators here would have seen, Jira segments the queries that it determines the flow into the slow queries log. And these are any request over 400 milliseconds. So it's telling you it's slow because it wants you to pay attention to it. If these requests were tuned a little bit better in terms of integrations, in terms of how boards are configured, then they wouldn't appear in the slow queries log in the first place. So we were interested as we were evolving how we're attacking performance, can we float up the threshold for that 400 milliseconds value? So it turns out it's a hard-coded value, but that may be an RFE down the line to actually to tune that better. So then, understanding of what Jira is, what's inside Jira in the first place, because when I'm working in a situation where I'm hosting tools to help developers, they're building Java-based web apps, and it turns out that Jira is a Java-based web app. The difference with Jira is that it's a Java-based web app with a database, and it's got an index or multiple indexes of the text and issues and comments and so on. So when I'm interacting with a Jira system doing a request, the request is being processed. It's searching for data in that index, and then it's returning it back. So as I said, this summit has 4 talks on performance. If you ever open up a support request on performance, this is probably the first sort of knowledge-based article that's going to be sent back from the support team. Check the performance of your index disk. The reason this is that there's if you can't read from the disk fast enough, that's going to slow down the requests and so on. So the point to emphasize, it's quite easy to find, is that never have your index disk on NAS storage. When we have these performance concerns, we tested index performance on on local disks, on SAN, even on RAM disks. But it turned out that our problems were elsewhere. It wasn't actually a hardware problem in the first place. So when we're administrators, and the utility that's provided in that knowledge base article lets you test the disk performance. So it'll give you a benchmark of where you're at compared to Atlassian's testing of where your index I/O performance is. So if you're log on to the server, you're going to see that there's actually multiple indexes within the index cache directory. There's a separate index for issues, a separate index for comments, and so on. So that's an important point I'll come back to later. So if the I/O is important, then you think, okay, there's obviously something to do with the size of the index is going to be relevant. So I haven't found any kind of benchmark figures to say what's the optimal size of the index, because there's so many factors at play between. I'm seeing Matt Dorr here on LinkedIn. He's laughing at my size here of the index. So available knowledge base articles will quote indexes of 1 gigabyte up to 18 gigabytes. But the best way to see where your index is compared to other users is to talk to experts or to reach out to the community, because ultimately it's the sprawl and the size of the index that's interacting with performance. So we did a basic level of analysis with the CPU and the web request. So the next available tool that was very useful for us was as a log analyzer provided by Atlassian. So if we've got the access logs, we can use Elasticstack or Splunk to parse the logs, but Atlassian already have patterns in their log analyzer to segment the access request to show you what's happening and plot this over time. So depending on the time period of access logs you've requested, it'll create this kind of graph, and it will also provide a set of top transactions. So the transactions then are patterns that Atlassian has identified which match to user activities in Jira. So if you see on this list here, there's probably about 20, but in other instances, I've seen up to 90 different transactions in a transaction log like this. And going back to is activity mostly write or mostly read, what you'll see when you use this analyzer is that most of the activity is related to boards, as in REST Greenhopper X board is an agile board, and there's another pattern then for a Kanban board. So this sort of analyzer can sometimes provide some quick wins, because when we started to pay attention to the access logs and see what's actually happening, we could see that the REST API traffic was 40% of the overall traffic. This is before we went to data center, and that was, relatively speaking, this integration was just trying to sync and search issues between a QA-based tool, let's say, into Jira, and the API traffic was totally overdone, overloading Jira. It was a matter of tuning the JQL request within the synchronization, tuning the time period to get it down to more reasonable value. So it kind of reminds me of the Heisenberg principle, not the Heisenberg from quantum physics, where basically the measurement is disturbing the experiment. If you've got APIs that are looking for status from Jira, until you go to data center, you can't let the APIs kill Jira, and the order of a single-digit percentage, even with data center, is a more reasonable amount of traffic for APIs. So the next thing is that we're starting to gather information about the access logs, starting to benchmark on segment with the analyzer, and we start to look at the database statistics of everything in our system. So we have lots of data, but we haven't really made any improvements yet. So it reminds me of Jack Nicholson's movie, As Good as It Gets. Jack Nicholson says to Greg Kinnear, "I'm drowning here, you're describing the water." So we need to have some way to know where we're at to be able to solve our problems. So fortunately, Atlassian did some great testing. I initially saw this testing in the 6.3 to 6.4 timescale, but they've repeated this testing with every release. And in this summit, they're making some more announcements of using this kind of testing to help validate plugins for data center. So what this testing was doing was looking at the database statistics I showed on the previous page and trying to correlate which aspect, if I increase it, is going to have the greatest effect on performance. Is it the number of users? Is it the number of projects? The number of groups? Number of comments? What's the what's the KPI for this? So what they found was that as they adjusted everything through their automated testing, they found that it's the workflows and custom fields have the biggest effect, and the workflows and custom fields have a big effect on the size of the index, and ultimately that's the cause of the performance problems. I would equate a combination of those two values as process sprawl, uncontrolled and overlapping usage of Jira. So one thing that's jumps out at me when I saw this page was that you can see that there's a lot of variability in usage. So these are sample customers. They're not sample bad customers, but it's showing that there's so much variability. Some instances have a huge amount of issues. Some instances have a large amount of comments. Some instances have lots of workflows, lots of users, and so on. So if there's no one way to use it, there's no wrong way to use it. And as I said, when I talked about the post-it notes, tools get a bad rap in Agile because people say it's all about interactions. But in this case, people have found a way to find a usage of Jira that works for them. So basically, one tool does not mean one way. So what helps us is that we had a table. This is in the testing page. It's available for anybody. We just added another line to this to track the size of our instance. Then we could see relatively, with a large amount of workflows and custom fields, this is the problem. The testing is saying this is the problem. This is where we need to go. Another interesting aspect on the testing is that it's showing you the typical response time of Atlassian's benchmark testing. So this is available in the Atlassian testing pages, and it's showing you at a transaction level. If you can create an issue in the same kind of time period as Atlassian benchmark testing, then you're relatively speaking in the same ballpark as their benchmark testing. And we asked Atlassian support for the strings and the access logs to match with all these requests, again, to replicate this table to benchmark ourselves against these kind of numbers. Atlassian frequently do a summary on the largest instances, and they summarize this in a little article, and this is a slide from that article. So this is showing that there's the table previously was showing a large amount of custom fields. There's even more out there. There's instances that are very large, but they're emphasizing limited amount of global custom fields to ensure performance at scale. So if you think about it, if you're retrieving an issue from Jira with the API, and there's 50 fields, it's going to be this amount of data that's returned if you return everything. If your instance has 1,000 custom fields and a lot of them are global, the width of your data is a lot bigger, and effectively the structure of the index is reflective of that. It's going to take longer to search. It's going to relatively speaking, be a worse performance than if it's controlled. So this little character here is Mr. Chatterbox, and one of the concerns we had when we had concerns about performance and we focus on the index is that, hang on a second, we've got integrations between our build tools and Jira. That's going to add references in their comments. Surely that's slowing us down. But it turns out that the comments are indexed separately from searches. So the JQLs used for boards are not affected by the amount of comments in stories. So one doesn't affect the other. So we self-identified ourselves as having a large amount of custom fields. Then we knew we had a problem. We described this to our users as process sprawl, that we were going to be communicating with them and go through an iterative process around it. So at the same time period as we were attacking performance this way, we were also planning a data center implementation. This was going to happen anyway with the scale of users and requirement to be for availability requirements. But it's actually helped us to go through the pain previously to understand about how the index works, because a data center implementation is another node with another copy of the index. So if the request hits one node out of the cluster, it can't be faster, because the same infrastructure is returning data. You can have more requests, but you can't have faster requests. So it's like, again, with my horsepower analogy, it's more beer, not faster beer. Now this little guy, if you've got a cluster and your API traffic is a small single-digit percentage, it's not a Clydesdale, it's like a Shetland pony, because you've segmented the API traffic using the load balancer. Lots of the plugins and lots of the boards use APIs, but their source referrer is Jira itself rather than an external source. So the sizing is different. Again, there's plenty of examples from Cerner and other implementations around this. So how we approached it then is we went through this iterative process, and it's not simple if you have to deal with the ownership of workflows, the reason why custom fields were created in the first place. But it's a matter of iteratively going through a target of what number you want to get to. It requires resources to coordinate with the teams that created the workflows and custom fields in the first place. And then what we did was using a measure of the index size, the database statistics relative to the customers, and then response times. So the index size is going to be smaller. The database statistics are going to demonstrate where the measures are, and the response time is going to be the response time is going to be better. So if we got into the problem from having a lack of control, then it's incumbent on us to use a change control policy when custom fields and workflows are being introduced. It's also very important around plugins, because if you had lots of plugins with global custom fields, again, your issue width is going to be bigger, because there's more data when you have a request. So this year, Atlassian announced project archiving. So there's a talk about that. So when they say if you archive projects, you will get a performance boost. It's the same thing. Your index is smaller. And this when we were working on these problems, we were working with Atlassian Premier Support. So we suggested lots of different requests for enhancements. So first thing we said was, can you mark projects as archived? Very happy that that came in. We actually asked them, even if projects are archived, people will still expect to search them. So can you put 2 indexes? We had other requests for enhancements around, if most projects have, let's say, 1,000 issues, and most boards are not spanning projects, why don't you have an index per project? Because Fisher and Crucible work this way. Anyway, this is a great improvement. But if it follows the same method, how many projects need to be live? Projects would be marked as archived, which would then require a re-index to take them out of the index. Atlassian already have measurable data around it. In the previous slide, it's talking about measuring the index size, response time, and performance improvements. And then as you're creating more projects, then time-wise, more projects will end up in the category of to be archived. So it's important to know what's your criteria, how frequently you're going to measure where projects should be archived or not. So as we learned more about it, the Jira Horsepower revisited would be something is adding to the performance, as in more capacity, core CPU speed, I/O, database performance, but it's an inverse relationship then with the custom fields. And as I said this morning, when Atlassian were talking about the performance index, it's kind of the same kind of meaning. Maybe someday on the server side, we'll be able to calculate some kind of performance index. Would be interesting exercise to do. Okay, to summarize then, with Jira Horsepower, it helps us to understand how Jira works, to understand when we're making changes, when there's integrations happening, to be able to ensure performance. The main thing is that to keep a handle on process sprawl. Change control, both for workflows, custom fields, and for plugins, to ensure proper testing. When Atlassian make their performance suite available, hopefully that's available to enterprise teams as well to test the impact of custom fields on their instances. It's very important to have usage guidance around how teams use integrations into Jira. If you've got an integration that will return all the data every time the request happened, or give me the data that's changed since the last time I asked you. The second one is the best way, because then you're minimizing the impact on Jira. Over the course of the evolution of what we worked on, we really kind of moved from a project-based mindset to a product-based mindset. We were focused on the service to our users, whereas at the start of this process, the team would have been named tools hosting, which is the implication of go to the Currys if you're in the UK, buy something, bring it in-house and turn it on. And then we've moved on to pay close attention to response times for users, so that they're going to get a service assurance. We're not going to get paged for performance concerns, and we're never going to get a ticket again saying, I thought Jira was sluggish today. Thanks very much for everybody coming here, and I welcome any questions.
So you mentioned a performance index that you'd like to see.
Yeah.
Typically with our customers, we look at average or mean page load time. Is that not a sufficient enough number for you to track, or are you looking for more than that?
Well, what we found is we had such variability usage that most users were happy, but some users that had poor configurations were very unhappy. So it was more important for us to make everybody happy, and if not tolerate kind of outlier issues. So again, talking about available knowledge bases, there's a knowledge base article around Kanban board slow loading. So is that Atlassian implementing it badly? Is it a poor filter? So we emphasize to users, if your board has a poor filter, you're going to get a poor performance. And because we were working with Atlassian Premier Support at the same time, I asked them to update the article on Kanban to say, be mindful of how you use custom fields and workflows, because this is going to impact performance too. And it's trying to explain it not in a technical sense, but in a common sense view. So if you've got a physical board, it's the height a human hand can reach. I'm pretty tall, so I get up to 8.5 feet. But you'd never have a board that's 3 stories high. But you'll see Kanban boards that'll page 15 times. It's that kind of practical usage guidance, and so it's some measure of performance to cater for edge cases as well as normal cases. I think is a good value.
You have mentioned the index as let's say a primer problem with Jira. Have you experiencing anything regarding the caching at the load balancer or at the reverse proxy level?
We didn't experience those kind of problems, but the purpose of my talk was to add to the knowledge base, and I'd be interested to see exactly what your issue was, because there's lots of talks on performance, and my one was around the customizations and the problems that causes. Thanks very much.
When you're starting a new instance, it's easy to be more mindful about the type of custom fields and workflow customizations that you are doing. But if you are managing an old instance that has a lot of custom fields and you don't know which ones are being used or which one people are just not using anymore, do you have any recommendation of any add-ons or any ways to find out those custom fields that can be deleted or that needs to have more attention?
So our approach was to go on the naming first and to see ones that had a similar purpose and to reach out to the teams that use those for a similar purpose. But it's an interesting case to try to relatively stack the most used custom fields and so on. I don't have an answer for that one, sorry.
Hello. One of your slides you mentioned data center, the index or the performance will not change much in the data center. So what is the techniques we need to follow or some guidelines we can get more performance in the data center?
Well, data center is adding more read capacity. So if you have more requests, more nodes will add more read capacity. But Atlassian, as far as I could see, emphasized that don't expect to make this faster. So it's what I said about the sprawl of process is going to affect the index. It's a matter of examining the I/O of your index, the I/O of the disk that the index is on, and your available CPU capacity. And then if you measure both of those and you calibrate them against what's available, then you should see an improvement in performance. And as Atlassian announced about project archiving, that's also going to help because people don't want to delete projects. They're marked as archived, but they're just segmented into the live index. So they've quoted, I think, 15-20% improvements.
We have no more time for live Q&A, but you can chat to Michael after this because there is a break from 3:30 to 4:30. But thank you, Michael, for sharing your wisdom with us today.
Thanks, everybody. Thank you.